Hello all, I am Hariharan R.Mohan. So today in this natural language processing project, I am going to present about the dataset of our project, home automation, about the NLP techniques applied for this project, and finally about the voice assistant. Now I'm going to explain about the dataset that we are took to our NLP project. MBQA, which is answering ambiguous open domain questions dataset we took for the NLP project. So, which is there are several questions and answers are provided in this dataset as well. So, for this project, we take the NQ Open, which contain several questions and answer dataset as well. So, these are the data text that are contained in the JSON file. For these are the questions, so which is it provide a question which is, for example, who is the main character in Green Eggs and Ham? Then there's a response which is Sam. So now we can also got many type of questions and many type of answers as well. So we use this data set to train our model in our project as well without any problem. Now I'm going to explain about the natural language processing techniques that apply to our home automation project. So for this project, let's start with the pre-processing part. So for the pre-processing part, the text are converted into the word tokenization, and then it goes to the lowercase side, and then the contraction will be play a major role, which means for example, if we say the word doesn't, so it will convert to does not. So that's called the contraction. So next it goes under stemming. Stemming is like a process of reducing a word to its word stem that affix to suffix and also prefix or to the root of words known as lemma. Like stemming is very important part in our natural language processing. When a new word is found, it can present a new research as well. So next, let's go to the lemmatization. Lemmatization is like one of the most common text pre-processing technique we use in the natural language processing, and of course in machine learning. So the root word is called a stem in stemming process, and it called lemma in lemmatization process, as we know that. So in this lemmatization process, we use the word net lemmatizer as well without any problem. Then for if you see that for I in device, so if we go up, so the device means the fan and light. If we detect when we speak about fan or light, if we detect the word fan or light, so it detect the word whether the current state of the device is on or off something. So if it recognize other than fan and or light, so it will start do the processing to answering the questions as well. So that's all the part for the NLP techniques that apply in our home automation project as well without any problem. Finally, I'm going to present about the voice assistant functionality. So the term of voice assistant will be used interchangeably in intelligent personal assistant, automated personal assistant, smart assistant, and virtual digital assistant. So many devices we users every day utilize voice assistant, and in our smartphone and inside in our smart speakers in our homes as well. So many mobile apps and operating systems use them without any problem. Additionally, in certain technology in cars, as well as in retail, education, healthcare, and telecommunication environments, it can be operated by voices without any problem. According to the growth, in future, voice assistant will take a major role in our technological world. So that's all for my part. Thank you.
Hello, I am Mohammad Tariq. I am going to present about our model training and implementation for our project. I have imported a few libraries which are TensorFlow used for our model training and the NumPy used for represent our data in NumPy array. Then we have also import pandas for data visualization and preparation. Our dataset are in JSON format, so I have import JSON to deal with it. We used tokenizer as word embedding, and then I also have import layers and models packages to use as model training. Lastly, I have also import matplotlib.pyplot to draw our results from our model training. The first step, I have import our dataset and only 3000 rows of question and answer we are retrieving from our dataset to use as data to train our model. Then from the dataset we only need response which is answer, patterns which is question, and tag which is a numerical values. And then we can visualize the question and tag values. These are the values we will use to train our model. Then at here, all the values are converted to lower letters. After that, we would do the word encoding using tokenizer. The unique number of words we have initialized is 10,000. Tokenizer.fit on text actually giving each word a numeric values. Then the text to sequence replaces values inside the trained array dataset with numeric values which are initialized earlier using tokenizer.fit on text. The path sequence used to make sure all the sentence lengths are same. Sentence length are same. This length determined by longest sentence in the array and add 0 values in front of shorter length array. The label encoder used to normalize the label which is in this case is tag. And then at here we able to see that every array has 20 values. At here we able to see the unique words are 5002. This is the part where I have trained our LSTM model. We used LSTM because it has the capability to remember long representation which is important in our case. At first, I initialized the input layer with the input shape of 20. And then the next layer is embedding and then the input dimension is 5003 and then output dimension as 10,000 as 1000. Next layer is LSTM layer which I have initialized the LSTM unit as 10,000. Then I have flattened the LSTM output so that it can be used as the neural network input values. The next layer is the hidden layer from neural network with 3000 neurons and using softmax as activation function. After that, I have compiled the model with sparse categorical cross entropy as loss function, Adam as optimizer, and accuracy as metric. Finally, I trained the model with 50 epochs. Here we able to see that the training accuracy and then loss of the training. And here we able to see that I have trained the model, and after that I saved the model as model2.h5. The h5 is actually the file format, and now I will explain how I have implemented the trained model inside our home automation. And here we are able to see that model2.h5 which I have imported inside our home automation project. And then at here we are able to see I am using the same coding. This is because the model's output and then our text representation should be the same. so that we might get the accurate response. And then the text contra is actually what we are going to predict now. And then the text contra will undergo whatever steps we have done before training our model, which are lowering, undergo tokenizing, and text to sequence and pet sequence. After that, I have import the model2.h file as a new model variable, and this new model will predict the response from the prediction input. After we have get the output, which is the output is actually the tag, and then we will use the tag as index of array, and we will put inside our response. Our response is actually the answer for the question, and then we will get our response.
Hello everyone, my name is Maheshwarman and I will be explaining about the two important features in our project, which are wake up call and speech to text. Okay, in here we created a function named predict audio, where it takes the audio as the argument. Inside the function, we imported speech recognition library, where the library enables us the process of converting spoken words into text in the Python. Next, we initialize a variable named R as the recognizer. Then, we created another variable named query, where it detects the audio that we speak and translates it into text. This translation is done using Google speech recognition. Followed by that, it will print out the text it recognizes. If there is no audio detected, it will print out the message, say that again please. So basically, this function is used for the wake up call. Means that when we open or start the system, the first thing we do is call it by an instance. In our case, we modify the way on how the system wakes up. Upon starting the system, first we will call it by name. Any name, not fixed instance name. Any one word name such as Junior, Boy, or Lambo, or anything else. By doing that, the system will predict and will recognize that the user is actually calling for them, because it is a one word. And it recognizes that the user is calling them, it will wake up. Again, if it doesn't recognize any of the word or it doesn't hear clearly, it will print out the message, say that again please. Now, I will explain about the speech to text. Here we created a function named speech to text. Inside the function, first we have initialized a variable named audio, where the audio records the voice the user speaks. After that, this part will save the recorded voice into .wav file named speech, and then we initialize another variable named R as the recognizer. In this section, using the saved speech.wav file as the audio source, a variable named audio_data will listen for the data in the such saved file and loads them into the memory, where from there it will pass into another variable named query, where inside the query detects the audio data in the memory and translates it into text. This translation is done using Google speech recognition with English language. The translated text will be printed in this section named print query.
So this is our interface. So first of all, wake word detection. If you can see over here, it will return the tensor neuron which is the query is happening. So let's start. Lambo. So as you can see here, it has detected the wake word and now it's listening to our queries. Lambo, tell me a joke. So as you can see here, if I say tell me a joke, and then it returns a joke, which is what did the buffalo say when his son left for college, bison. It's a very bad joke, but I think it's a decent one for a voice assistant. So let's test a home automation feature for our Lambo voice assistant. Lambo, turn on the light. So right now when I say turn on the light, it will return me turning on the light. Lambo, turn off the light. So if I say turn off the light, it will return turning off the light. So that's for home automation feature. We can actually search for things in our voice assistant as well. Lambo, where is Malaysia? So as you can see, when I say where is Malaysia, it returns a web script info from Wikipedia of Malaysia. So this actually feeds up the search space of the keyword that we said once it converts from speech to text, and then pass the keyword to the web, and then it searches for that, and then it scrapes from that, and it returns us the info. Lambo, open YouTube. So as you can see here, it opens up YouTube but in a browser which is intended as the default browser. So it opens up anything that you ask. You can open YouTube, you can open Facebook, anything that you want using our voice assistant as well. Lambo, thank you. So I think that's all, guys. When I say thank you, it returns my pleasure. So this concludes our voice assistant, our Lambo voice assistant overall. Thank you so much.